Hello everyone, how are you all? This is Funny. You are watching Funny HS Info. Today I come up with the topic H2S safety. In this presentation, we know about what is hydrogen sulfide, which means H2S, the properties of hydrogen sulfide, some places where H2S is found, what are the health effects of H2S exposure, how to detect H2S or detecting methods, PP required to handle H2S, safety measures to be taken at H2S handling areas, and emergency response procedure in case of H2S exposure. So let me begin with what is H2S. H2S is composed of 2 hydrogen atoms and 1 sulfur atom. It is a colorless gas which is flammable, toxic and corrosive. It is heavier than air and tend to settle in low-lying areas. At higher concentrations, no odor can be detected because H2S causes paralysis in the olfactory nerve which affects the ability to smell. It goes by many names like H2S, sour gas, sewer gas, stink dump, sulfur hydrogen and killer gas. The properties of H2S. First one, color. It is, as I told you, it is a colorless gas. Odor, commonly referred to as odor of rotten eggs at low concentrations. No odor at high concentrations. Vapor density 1.189 in its pure form. It is heavier than air. Exposure limits 4.3 to 46% by volume in air. Auto ignition temperature is 260 degrees centigrade. Flammability forms explosive mixture with air or oxygen. When coming to water solubility, 2.9%, which means 2.9 grams per 100 ml of water at 20 degrees centigrade. Reactivity can react with iron to produce iron sulfide, which will ignite in the presence of air unless it is kept wet. And last one, hazards. H2S is flammable, toxic and corrosive. So next one, places where H2S is found. Oil, gas and petroleum industries. H2S occurs during oil production, storage, transportation, in refineries where H2S is separated from natural gas or crude oil. Wellheads, pumps, piping systems, oil and water tanks, flare stacks, bottom of the drilling rigs, sludge filters and mud pits. And next one, chemical industries. Production of more than 70,000 different intermediate and final products made of organic and inorganic substances. Example, production of sulfur and sulfuric acid, inorganic sulfur recovery, purification of nickel and manganese, treatment of metal surfaces and production, and production of highly compressed lubricants, etc. Next one, heavy and metal industries. Metal and aluminum melters, ship construction, flotation of ores, treatment of metal surfaces, etc. And next one, pulp and paper industries. Related to the production of paper from fibers such as wood pulp, the pulp and paper industry is the largest source of industrially produced H2S during processing, with breakdown stock washes during combustion of the pulp liquor. And last one, public utilities such as sewage and water treatment plants, landfills, geothermal systems, etc. Biological composting of waste in landfills, dewatering of sewage sludges, etc. These are the sources of H2S gas. When coming to health effects of H2S exposure, the main effects are eye irritation, disable sense of smell, block the cells from receiving oxygen from lungs, dizziness, nausea, shocking, confusion, unconsciousness, sore throat, coughing, death due to asphyxiation, and skin irritation. Based on the level of exposure, the health effects may vary. Let me brief about this. For example, at 1 to 10 ppm, we can observe or feel rotten egg odor. At 20 to 100 ppm, severe irritation of eyes and breathing passages. 100 to 250 ppm, severe irritation of eyes and breathing passages, cough, headache, nausea, loss of sense of smell. From 250 to 500 ppm, difficulty in breathing, fluid in lungs, vomiting, dizziness, loss of coordination. 500 to 750 ppm, stumbling, collapse or knockdown, loss of coordination. And 750 ppm above, death within the moments to minutes due to the respiratory paralysis. Next one, how to detect H2S. There were different methods or equipments used to detect H2S based on the requirement, process or industry. Some of them are mentioned here. First one, coated strips. These are the lead acetate strip, usually turns brown to black due to the presence of H2S. The degree of color indicates the gas concentration. Second one, badges. These resembles a credit card. These monitors can be carried and will change color depending on the gas levels. Third one, tubes. It is like a size of a pen. They provide an appropriate measure of H2S concentrations. The tube changes color depends on the H2S level. Fourth one, single gas monitor. These can be used to continuous monitoring during working or operation, carried on by individually. Fifth one, multi-gas monitors. These can be used to check the levels of gas in working environment periodically. These are used by safety professionals. Sixth one, fixed gas monitors. These are located at work location for continuous monitoring. And seventh one, area monitoring devices. These are the devices to be used in shutdown operations or in case of emergency monitoring operations. These are the equipments used to detect H2S gas. And next one, personal protective equipment to be used while handling H2S gas. First one, eye protection, safety goggles with the side shields, face protection, face shield and safety goggles, hand protection, use neoprene hand gloves, body protection, fire resistant clothing like apron or coverall, foot resistant anti-static safety shoes, respiratory protection, half face mask, full face mask, airline respirators, self-contained breathing operators, breathing air suit, etc. And emergency equipments, hooded filter escape, compressed air escape with mask. And next one, safety instructions. Every work site should have various safety measures in place to protect against H2S exposure. These are the precautions to be followed at H2S handling areas. Check and ensure the availability of audible and visual alarms working properly. Gas ignition hazard must be clearly marked. Continuous atmosphere monitoring to be required. Explosion proof mechanical ventilation only to be used at H2S handling areas. H2S awareness training program and emergency procedures must be conducted. Maintenance of good communication. Make sure detection equipment are readily available and are working properly. A buddy system for mutual safety to be followed. Strict enforcement of no smoking regulations. Care to avoid low-lying areas. Provision of warning signs throughout the site. Maintenance of protective equipments including breathing apparatus. Work site should strive to label all piping valves that carry H2S. Availability of material safety data sheet or safety data sheets at work location. Proper testing of confined space before entering to ensure good ventilation. Availability of wind socks to check wind direction. A minimum of 2 defined safety escape routes must be located. Use exhaust and ventilation system to reduce H2S levels. Establish a proper rescue procedure to rescue someone from H2S exposure. And exposure to or above 100 ppm considered as ideal H condition, which means immediate dangers to life and health. And last one, emergency response procedure, which means if there is any leak of H2S gas or if anybody exposed to H2S gas, how to respond. We have to follow these 7 steps. The first one, evacuate. Go to a safe area immediately by following wind direction, which means cross wind direction. Move to higher ground if possible. And second step, alarm. Call for help by using different communication methods. Next step, assess. Do a head count, consider other hazards. Fourth one, protect. Put SCBA, self-contained breathing apparatus, before attempting any rescue operation. Next one, rescue. Remove the victim to safe area. Next one, revive. Apply CPR if necessary. And last one, medical aid. Arrange transportation of victim to hospital. This is the emergency procedure. This is about H2S safety. Hope you understand. Thanks for watching. And please don't forget to subscribe and share my videos. Have a safe day.